Welcome back to lecture 10.2, lecture 10.2, where we're going to briefly talk about the kinetic theory of gases for a diatomic molecule. Okay, so everything we did last time in our kinetic theory of gases, we had a single atom. We should usually think about it as helium. It's the most ideal of our ideal gases. But now I want to consider, for example, air, where I have this nitrogen molecule with a bond between them. Okay? So I said I should neglect interatomic and intermolecular forces, and I don't mean this bond here. I mean the ones between molecules, for example. Okay, so we know that the internal energy of this system, right, should be entirely the kinetic energy. Right? So let's deal with that one first. So just like the monatomic gas, we have 3 degrees of translational motion. But now we have 2 degrees of rotational. Remember, that's this one and this one. But this one, where they just spin on this axis, we can neglect. There's no moment of inertia, and so no energy associated with that. So 2 rotational. Okay, so remember that our we can do this from either saying, well, we have the sum, right, of all of our molecules, and we're going to have, basically you can say we have 1/2 mv squared for each of those degree of freedom, and we have 5 of them. So this is 5/2 mv squared. Or 5/2 kBt, right? But the key, so that works out perfectly. But remember, so you can also write this as 5/2 nRT. Sorry, 5/2 the number of molecules RT. So really, if I had all of them, it was the sum. I really should have the total number of them, nkBt, or little n here. Now, one thing to point out is really this is the microscopic way of thinking, where we have how many atoms we have and the energy per atom, and this is really the macroscopic way of thinking. We have how many moles, right, and then the energy per mole. Okay, now the question though is, so that's for our internal energy. What about for our ideal gas law? Should the ideal gas law change for a diatomic molecule? So it actually turns out that we shouldn't, because our molecule has a center of, when we thought about the force that we were applying to a wall, right? From, say, a molecule bouncing off instead of a molecule bounces off and changes its momentum. It has nothing to do with the rotational degrees of freedom. It's really the center of mass motion, right? Center of mass motion. And so only the translational energy is relevant. So our calculation for the monatomic gas can proceed identically as the diatomic. Okay, so that's all I wanted to say for the kinetic theory of diatomic gases. Now we're going to do an example in class where we're going to actually calculate the average speed of a nitrogen molecule in the room, and we're going to calculate how much, what the internal energy of the air in the room is. We'll do some quick estimations. Okay, I will see you next time in lecture 11.